Hello friends, welcome to Math Solution Academy. Now we talk about real analysis. Today my topic is uniform continuity of an integrable functions. Now go to the problem. The first problem is let f be a function on closed interval 0 to infinity 2r defined as f of x equal to integration 0 to x sin square t square dt. Then the function f is uniform continuous on semi-closed interval 0 1 but not open interval 0 1, uniform continuous on open interval 0 1 but not semi-closed interval 0 1. Third option is uniform continuous on both semi-closed interval 0 1 and open interval 0 infinity. And the last option is neither uniform continuous on semi-closed interval 0 1 nor uniform continuous on open interval 0 to infinity. Now we try to solve it. The functions, first of all, the function f is defined on 0 to infinity to what? Such that f of x equal to integration 0 to x sin square t square dt. Take any 2 points in take any 2 points in closed interval 0 infinity. Then f of x1 minus and take it f of x2 minus f of x1, and this is equal to sin square t square dt, and this is 0 to x1 sin square t square dt. So this became 0 to x2 sin square t square dt plus 0 to x1 sin square t square dt. We just change the lower and upper limit. So this becomes x1 to x2 sin square t square dt. Now we take the modulus. So mod of x2 minus f of x1, this is modulus integration x1 x2 sin square t square dt modulus. And from the properties of integration, this is less than equal to x1 to x2 sin square t square dt, and this is generally x1 x2 dt. So this is x2 minus x1, and so mod of f of x2 minus f of x1 can be written as less than equal to mod of x2 x1, and here since mod of sin square t square less than equal to 1. So from here you see that this is actually Lipschitz condition functions. So therefore every Lipschitz condition function is uniform continuous, and for this reason the function is uniform continuous on closed interval 0 to infinity, since x1 x2 are arbitrary point in closed interval 0 to infinity. So therefore the functions f is therefore or hence f is uniformly continuous on closed interval 0 to infinity. You can check it yourself. That is, what is uniform continuity? Let let us choose an epsilon greater than 0, then there exists a delta greater than 0, such that if mod of x2 minus x1 less than delta, this imply mod of x2 minus x1 less than delta, and take it and epsilon equal to delta. So for each for each epsilon greater than 0, there exists delta greater than 0. Exactly, this is equal to epsilon, such that x2 minus x1 less than delta. This implies that mod of x2 minus x1 less than epsilon. So therefore f is UC. UC means uniform continuous on closed interval 0 to infinity. So in this way you check that this is UC. Actually the main aim of this problem is find this. So if you find this, you say that the function is UC, and this is clearly UC on both semi-closed interval 0 and open interval 0 infinity. Thank you.